The sine rule is a special rule which helps us work out lengths and angles of non-right-angled triangles. So if we look at this triangle here, it's not right-angled, and this is how we label it. Because it's not right-angled, we can't always use opposite, adjacent, hypotenuse. Instead, we label the angles with capital letters, A, B, and C, and then the sides which are opposite the angles, we use lowercase letters to label. So we'd have, I generally call the capital A big A, and then the opposite side to capital A would be little a. So capital B, capital C, little c. And that's how we would label any non-right angle triangle. Here are some quick questions for you to try. Can you sketch these triangles and finish labeling them? So here's the first one. Pause the video, sketch it and label. And when you're ready for the answer, press play. So it should be labeled like this. Little a opposite big A, little b opposite big B, and the remaining side and angle should be little c and big C respectively. Have a go at labeling this one. Okay, so we would have little c opposite big C and big B opposite little b. And then the remaining side and angle is going to be A. So we have big A as the angle, little a as the side. One more. So sketch and finish labeling. And you should have this. Now, let's have a look at how we can get the sine rule. If we look at this non-right angle triangle, how could we split it up into two right-angled triangles? You can probably see two ways. Well, one way would be to draw a perpendicular line down from C, well, a line from C which is perpendicular to AB, like this. Then, because this is perpendicular, these are going to be two right angles. We can now think about the opposite. So we can see that if we think about this in terms of right angle triangles, this side here is opposite to A, and it is also opposite to B. So we could use trigonometry. We could say sine A, in fact I'll type this, but we could say sine A equals opposite over hypotenuse, and hypotenuse of the triangle here on the left is B. So we would have sine A equals opposite over B, so we can rearrange to get opposite is B sine A. Similarly, we could do the same with the triangle on the right. Sine B is opposite over A, little a, so opposite is A sine B. So we have two expressions for the opposite, and because they both equal the opposite, we can make them equal to each other. So we have B sine A equals A sine B. And we can then divide both sides by A and divide both sides by B, and we end up with the sine rule. A over sine A equals B over sine B equals C over sine C. That's the sine rule from when we want to work out a side. I'll just show you now how we would do so with an angle. Just one little note, I haven't proved that it's the same as C. You'd have to draw another right angle triangle to do that. So we have A over sine A equals B over sine B equals C over sine C, and this is what we'd use to find a missing side. And the one on the right is what we would use to find a missing angle. And generally, you'll never have to use all three letters at once. It's always going to be sine A equals sine B, or sine A over A over equals sine B over sine B over B even, or B and C, or possibly C and A. You're probably not going to see, you're never going to see all three. Let's have a look at this example. So we want to find the side AB. To do this, I'm first of all going to label my triangle. So I want all of the sides with small letters like this. And we have two angles inside. That means we're going to use the sine rule. And what I'm going to do is write this in the form A over sine B, A over sine A equals B over sine B, etc. So let's substitute in what we know. So we want to find AB, which is C, right? A to B is C. We want to find C. So I'm going to write down 4 over sine 50, right? Because I'm using B and C. So little b is 4, big B is 50, so I have 4 over sine 50 equals little c over sine 70. To get c on its own, I can multiply both sides by sine 70, which gives me c is equal to 4 times sine 70 over sine 50. And if I put this into my calculator, so I'll just show you now. So 4 times sine 70 over sine 50, I get 4.91 centimeters. Here are some quick questions for you to try. Please pause the video now and have a go. When you're ready for the answers, press play. Here are the answers. So you should end up with 13.47 centimeters, 14.36 centimeters, and 9.58 centimeters. For the last one, you've got to find the missing angle B first, and notice that it's 40 degrees, otherwise you won't be able to find little z. Sometimes you want to find missing angles using the sine rule. So in this question, you want to find missing angle x, and then hence angle z. We have two sides and the non-included angle. We have y, 40 degrees. So that means we need to use the sine rule. So what I'm going to do, this time I want to find angles, so I'm going to write down sine A over little a equals sine B over little c, and so on. And just using the notation of the question, I'm going to write down sine of angle x over little x equals sine of angle y over little y. Okay, so you just got to get used to using whatever notation you have. I'm going to substitute my values in. I know that little x is 9.4, little y is 6.1, and big Y is 40. I want to find x, so I'm going to get sine x on its own by multiplying both sides by 9.4. This will give me 9.4 times sine 40 over 6.1. So we could put it in this way, 9.4 times sine 40 over 6.1, giving you 0.9905. But you could also do this. You could do 9.4 times sine 40 over 6.1. Excuse me. 9.4 times sine 40 over 6.1, giving you 0.9905. Then to get x on its own, you need to do shift sine minus 1. So again, I'll just show you that if you've forgotten that from previous trigonometry. Shift sine and you get 82.10 or 82.11 actually is what I get. Yeah, 82.11 degrees or thereabouts. Then to find x, what I'm going to find z, sorry, I know that x is now 82.11 or thereabouts. You might have a slightly different answer depending on your rounding, but that's okay. So to find z, we add up the angles we know. 40 plus 82.11, so that's going to be 122.11, and then we subtract from 180 to give us z. 180, and that will give you 57.89, which is what we wanted. Here is a practice question for you to try. I'd like you to find angles y and z. Please pause the video now and have a go, and when you're ready for the answer, press play. Here is the answer. So this time we have two sides and the non-included angle, so we use the sine rule. We end up with sine 105, not sine 105, we don't end up with that, let me change that. We end up with sine of 110 over 14.4 equals sine of y over 9.8. To get sine y on its own, I multiply both sides by 9.8. So sine y equals 9.8 times sine 110 over 14.4. So sine y equals 0.6395. And then to get y on its own, we take inverse sine of both sides. So on my calculator, I could just do shift sine ands, right? Shift sine ands, giving you 39.76 degrees. That's y. And to find z, I need to do 110 plus 39.76 and subtract the result from 180, because angles in a triangle add up to 180. Which should give me 30.24. So z should be 30.24 degrees. Here is a challenging question for you to have a go at. So pause the video now and have a go at it, and when you're ready for the answer, press play. Here is the answer. You should end up with about 85.28 degrees for C, and then you can use that to work out that AB is 14.97 meters. So quite a tricky question. So basically I've worked out B first and I've used that to find C, and then you've used that again in the sine rule to find AB. Here's a final question for you to try. This is from the GCSE. So given that AB is parallel to ED, calculate the length of AB, and then see if you can write down ED, and it might require some knowledge of similar shapes. Okay, here's the answer. So firstly, using alternate angles, I have, so A is also 40 degrees by alternate angles because of the parallel line properties. We can then work out this angle here, so this angle C, or ABC. This is 60 because 80 and 40 is 120, so the missing angle here is 60. And then vertically opposite angles are equal, so we have 60. We can now use the sine rule to work out AB, which is about 6.78 centimeters. And then, because the triangles ABC and CED share this angle of 60 degrees, and also they share these angles here, all the angles are equal in fact, you've got 60, 40, 80 for both of them, that means the two triangles are similar. So, they're going to be linked by a scale factor. To work out what the scale factor is, I just need to work out two corresponding lengths, so 9 and 6. We divide them, that gives us our length scale factor. So if we know what AB is, ED is just going to be the scale factor 1.5 times whatever AB was. And that should be our answer there.